Here is a simple problem. We have to find the range of this function. Sine of pi of x square plus 1, greatest integer function by x power 4 plus 1. Okay, so there is a greatest integer function here. So whatever x can be any number. X square plus 1 and greatest integer function of that. Greatest integer function of this will always give an integer. Right, x square plus 1 is 2.1, 4.1, it doesn't matter. So whatever is this is always an integer. What does that mean? The numerator is sine pi into some integer. Basically, it can be sine 1 pi, 2 pi, 3 pi, 4 pi, 10 pi, whatever. Sine some integer multiple of integral multiple of pi. What does that mean? The numerator is always 0. Right? Sine pi, 2 pi, everything is always 0, right? The sine function, how does it go? It goes like this, right? And this is pi, this is 2 pi, this is 3 pi, this is 4 pi, likewise, or 0, minus pi, minus 2 pi, likewise. Okay, so all multiples of pi, sine is always 0. What does that mean? The numerator in this function is always 0, irrespective of the denominator. We don't even need to worry about anything. Whether x is integer, non-integer, it doesn't matter. This function will always give sine and integral multiple of pi, which is always 0. So the range of this function is 0. Very simple problem. Another super easy problem. We are given a big function like this. Sine inverse x square plus 1, x minus greatest integer function of x log x, whatever, whatever. Now, what is the domain of this function? That is the question. Now, here we can see there is something called under root minus x square, right? And x square is always positive, minus x square is always negative. And the only way we can have this thing under root minus x square, obviously this is always negative. If then even if we make this 0, let's say even if x is 0, then this becomes root 0, but root 0, which is 0, which is again in the denominator. So essentially what that means is x cannot have any value. If this was in numerator, probably x we can at least accommodate 0 because root 0 is still fine. But here, because it is in denominator, we cannot have this 0 in the denominator. So essentially what does that mean? No value of x, whatever x is, we cannot we cannot have an x which will be valid for this term, right? So what does that mean? The domain of this definition. So there is no domain, right? That means the domain is null set, nothing, right, guys?